what I'm going to do is I'm going to go through a few examples of this just to show you what this looks like. And so let's have a look at these questions here. So this is from Maths in Focus 7.07, exercise 21. So the first part is we want to sketch f of x is equal to x squared plus 2x minus 3, and then sketch y is equal to 1 over this function. So I've got my Cartesian plane down below. I'm going to quickly go through sketching this f of x because we've already done this. This is sketching a quadratic. And so f of x is equal to x plus 3, x minus 1. And so I've got two x-intercepts at -3 and 1. I'm going to just check my notes. So here, I'm going to draw f of x in this light red color. So I've got -3, 1. And so I'm going to get a graph that looks like this down here. Now, you would need to find the vertex as well. I've already done this in advance, just so to make this a little bit easier for us. And I know this is a bit wonky, but that's fine. I've got the vertex, or this is called the local minimum, because it's a point that's below every point either side of it. This is at 1, -1, -4. Okay, so that's the point here. That's this, what's it called? That is this quadratic here. Now, what we want to do is we want to sketch f1 over f of x. So let's go through these points. So the first part is for the new graph, the same sign for all the new graph has the same sign for all values of x. So I'm going to look here. This graph is positive on this side of, so I'm going to do this in blue. So if you have a look, this side of -3, this side is positive. And on this side of +1, this is positive. So my reciprocal graph is going to be positive for those two sections. But in between, it's negative, and so it's going to be negative in between those values. Okay. Also, it might be helpful for me to draw the y-intercept, which is at -3. Okay, cool. The next step is the zeros of f of x correspond to the vertical asymptotes. Now, the zeros are just where my x-intercepts are for my original function. So I have an x-intercept at -3, and I have an x-intercept at -1. So those two dotted lines are going to be my vertical asymptotes. Those are my vertical asymptotes for my reciprocal function. Okay, that's the second dot point. Now, if f of x goes towards infinity or -infinity, as x goes to 0, then there's a horizontal asymptote. Now, if you have a look on my graph, there's 2 points where we go towards infinity. On the left-hand side here, my parabola is going towards infinity, and on the right-hand side here, it's going towards positive infinity as well. So what this tells me is that my reciprocal function is going to go towards 0 at those 2 points. So at those 2 points, the graph is going to go towards 0, or from the positive side. Okay. If the curve intersects at y is equal to 1 or -1, so does the other. Now, here, I haven't put on any points where my graph is equal to +1 or -1. But if you have a look, there's going to be a point over here where it's equal to +1, and over here where it's going to be equal to +1. And there's also going to be a point here where it's going to be -1 and -1. And so my reciprocal function is going to touch at those particular points. You can find them. I'm going to do that I can do that quickly. So here, for example, this is going to be equal to 1 when, let me think about it for a second. 4 plus. Okay, you can solve that separately. I'm not going to do it here. But yes, that is the next part. Okay, and when one curve is increasing, the other one is decreasing. So for example, that's what we have already here. So the graph is increasing on these green edges, so the reciprocal is decreasing. And we get closer and closer to 0, it's decreasing, so it's going to be increasing at those points. So here, it's going to be increasing at these points. So in here, it's going to be decreasing to a negative value on those points. And the final point here is when one curve has a local maximum, the other one has a local minimum. And so here, if you have a look, there's a local minimum at this point, -1, -4. Because I'm taking the reciprocal, I'm going to have a local maximum at that point. But instead of it being at -4, I'm going to need to take the reciprocal of that value. So here, I'm going to have a local maximum, not at -4, but this is going to be -1, -1 over 4. Because I need to take the reciprocal. So here, -4 in my original graph is going to become 1 over negative 4. And so that's why here I've got negative 1 over 4. So let's put this all together and draw one graph using that. So I'm going to do this in my dark blue. So I'm going to put this all together. When on this side, x was going towards infinity in my original graph, so it goes towards 0, and then it goes towards infinity because we've got a asymptote. And on the other side, I've got this exact same thing. Now on this side, I've got my graph goes towards negative infinity. It has a local maximum at negative 1 over 4. It goes back down. Now the other thing is, we had an y-intercept at negative 3. That negative 3, in the same way that negative 4 went to 1 over 4, that negative 3 is going to go towards 1 over negative 3. So we have a y-intercept this time at negative 1 over 3. Okay, so there we go. That is my graph of my reciprocal function. Bit tricky at first, but there's a few steps. If we go through those steps, there's a systematic way of approaching how to graph this function. Now we want to find a domain and range, so let's do that. So the domain, this graph exists for all values of x except for 2 points, our asymptote. So our domain is going to be all of x is not equal to negative 3 and x is not equal to 1. And we can write that in, in interval notation. So it goes from negative infinity to negative 3. Then we have the values between 3 and 1. And then we have 1 to infinity. So that's our domain. Okay, our range, if you have a look on the positive side, well, our range is y is not, well, first of all, we have an asymptote at 0. So y cannot equal to 0. But along with that, if you have a look on the negative side, we don't actually go between that local maximum to 0. So on the other side, I'm going to have y is also less than or equal to negative 1 over 4, which is our maximum. If we wanted to write that in function notation, we've got on the positive side, we've got 0 to infinity. And on the negative side, we've got, and it's going to be a square box here, negative 1 over 4, which is our maximum, towards negative infinity. So that is our domain and range. And I can go through this in a little bit more depth in the class that we have scheduled. Okay, cool.